All right, so I'm gonna. My name's Coach Hemingway. I am a secondary math teacher. I teach, high school math. This is like the first video. Most of my videos have mainly been for my classroom use, but this is my first video that's almost aimed at teachers in a way. But students can probably get a lot out of this too. The first thing I'm going to say is this is my tower of operations. Now, most of you have heard of PEMDAS. You've used PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction, right? The main thing that I've found with students is they get locked into parentheses first, exponent second, always multiplication next, and then division, which multiplication, division, it goes left to right. They're not unequal partners, I guess. And the same thing with addition and subtraction, especially you algebra teachers, like pre-algebra even, you guys get into when you start adding and subtracting integers, you get into keep change, or I used to do minus and negative. It's just like minus and negative is like plus a positive, but that's because I'm weird and different. A lot of you guys can realize I'm weird and different. I see things differently. Um, the same thing, like they don't end up seeing the connection between the two. A lot of algebra students see these things as separate things and they get really confused. And this math is really supposed to be very simple. It's really, really simple um, and fun. So I kind of developed this pyramid thing. Now I'm going to give some kudos to the Math Equals Love blog with Sarah Carter. She has all types of stuff that she gives out to teachers all the time, and she's way, way, way too generous and helpful in every single way. And I thought I had made this all on my own, and that it was genius and original. And I went to her site because some other math teacher at my high school told me to check it out. And I don't remember if it's exactly the same, but I saw something extremely similar to this. And I thought, oh, great, I've reinvented the wheel completely on my own. Um, but either way, I use this a lot. I don't know exactly how she uses it, but, kudos to her for also seeing that PEMDAS by itself is confusing and really kind of could be much better. So in my pyramid, I did way too fast. I use this thing for everything. Like from pre-algebra all the now I don't teach pre-algebra, but from pre-algebra skills all the way up through. I mean, even calculus and pre-cal a lot. Um, Algebra two I use this in every single chapter and unit and everything we do. But this is just great. So the big thing is this is my tower of operations, and it's kind of nice because we can all see how these things work together. I mean, way down here at the very bottom would be like counting, right? But way back when numbers first started, and then everything up here is a shortcut or undoes that stuff. So if I'm going to start counting faster, I'm going to go into addition. Right? If there's 10 turtles out there that I have to count, if I break it up with another partner of mine, I say, okay, you count those, I'll count these, and I count 4 of them and they count 6 of them, we can get to 10 a lot faster than me having to individually count them. That's all addition is. It's doing it faster, right? And if I have a group of adders going around and they're all adding the same thing, that's all multiplication is. It's just doing addition faster. And powers is just doing multiplication faster. So they're all built off of each other, which I think helps out students if they see how they're built, And subtraction is the inverse or the undoing of addition, and division is the inverse or the undoing of multiplication, and roots are the inverse and undoing of powers. And I also think it helps out students if they see that if I'm just counting stuff, I can build addition is built off of that. I can't go from counting all the way up to multiplication, right? If I have a pile of stuff, I can't use multiplication to figure out how many things are in there. I can break those things into like groups of 3, and then so now I have groups of 3, which is kind of like using addition. And if I'm going to be adding up all those threes, I can see how many times I'm doing that, and that gives me multiplication. All right, I can't get from addition up to powers. I have to have multiple multiplications before I have powers. So if I'm grouping my multiplications of the same thing over and over again, that's how I have powers. And I think it's easier when you get to the more advanced math to show students how these things are built off of each other. and this kind of like how I got to the pyramid thing. I don't know how Miss Carter got up to the pyramid on her own. Um, but I saw it as these are building blocks, and I grew up loving Legos, and my son loves that stuff too. And they're building blocks, so they build all up. And I really love this. I do have to give 100% credit. I stole from Miss Carter. She stopped using parentheses and started using the word groups. And before, my Tower of Operations had parentheses up here, um, because the students get confused with the other thing I stole from Miss Carter, the vinculum, the big fraction bar that contains the hidden parentheses, and a radical that has hidden parentheses. So if we just start calling it, if kids get locked into, I don't see parentheses there, why do they come first? If we just call them groups, it's easier for them to see grouping, which is not always a set of parentheses. There's a whole different, sets of groups out there and ways that they appear. That's what I'm looking for, other than just parentheses. And a lot of people get locked into parentheses. So those are groups. So this is my Tower of Operations. And this is going to be my first video. Just, hey, this is why I use my Tower of Operations. We're going to get into how I actually use this. And I'm going to try to see if I can go all the way from like 7th grade math using this up to pre-cal, well, algebra 2 at least. It's going to be a long night otherwise. To how we use this for like everything we do. Another big thing that kind of pops in my mind, because I'm here at a technology conference this weekend, and I've been hanging out with a lot of people that are big into coding. Which is becoming more and more prevalent. If you have younger kids that understand a little bit of the basics of coding, they've done some mathematical operations and stuff. These are like our coding words in the math field. These are our commands, if that makes any sense. That's what these are. They're the verbs. If you are an English person, these are the verbs of the math world. Our numbers are our nouns. They're our subjects, are the things that happen. These are the doers, right? Especially when you get algebra 2 students that are weak in foundations, they'll start seeing, like if you do logarithms, they'll start thinking that they can do things to addition. Well, they're not doing things to addition. Addition is a doer, and you can do an opposite thing. This is like jumping, and that's like ducking, right? You can do an opposite thing, but you're doing it to stuff. It's the numbers that are changing. These are action things. I guess you find out what your students really get. Find out what clicks in their head, because math can work for it. Whatever it is that clicks in there. The big thing, these are doers. These are operators. That's why it's the Tower of Operations. And I'm going to kind of cut this off and start to like actually use this in the next video, just because I'm like ready to go. And this is the Tower of Operations. These are, I like to say they're all of them, but you really super big math geeks out there know that there's other operations out there. Yes and no. I guess I could argue both sides of that, but in a way, there's functions. Functions are also they're doers also, but they're in the coding world, these would be like a set of operations, and they do things all on their own. They're like a set. I don't know, but we'll explain that when you're ready for it. I don't want to confuse any people that are not quite at that level yet and still watching this video. So we're going to follow this up. After this, we're going to start doing the actual, basic operations with expressions, and then we'll get into equations, and we'll see what, where I go from there. All right. Thank you.